that works. That's what you're supposed to do. And as far as I know, I don't know why you wouldn't want to do it with a fork mount too. Is that, Bob, does that make sense? Well, it's just not so easy.
Well, the beads are already off balance.
They're automatically off balance.
Yeah, because the one motor is on one side.
Oh, all right. So you don't have to deal with it.
I've got a Celestron Gem. When you say east side, you're talking about the two
balance on the west.
I'm saying whichever end of your arm is on the east, that needs to be heavier. So if you're shooting with something in the east, if you're shooting with something in the east, then your counterweights are on the east side of the
Keeps pressure on
and
the
you want that to be heavier. So that the mount is trying to upright itself and you're pulling against it. But now if you shoot into the west, now your scope's going to be on the east side and you need to rebalance so that the scope is not moving. Right? And so you want to kind of keep a rear of it. And then I have a trick with my setup. I set my scope up, put the camera on. I balance for east side heavy when I'm looking into the east because that's usually where I start, something in the east. And I have two weights down there and I know that I'm east side heavy at that point. And then later in the night, if I ever switch to west side, I know that I just have to take one of my weights and loosen it and move it up by one thumb's distance. And move it up that much and I know that I'll now be west side heavy. So I switch my counterweight by in the dark, so I feel it and how much I move the weight up. And just guess at it. So, you just take care of that whenever you move your.
You're talking about a slide weight that's on the tube itself.
It's on the counterweight. It's on the counterweight.
Oh, the counterweight.
The counterweight. Right.
Oh, the
counterweight
up or down. Okay.
Up or down.
I wasn't sure which direction you're talking about. The tube up, down in the cradle, or the balance, the counterbalance of the tube itself.
Just the weight on it. The weight on the tube.
Okay.
And this may be too fine a point, but it's something that I'll show you an example of how it really works, or how it doesn't work. Jeff talked about this last week, and it's a very cool thing that you want to do really if you're taking long exposures, and it's to dither. So you really want your software to take an exposure and then shift the image just a random amount.
I don't have to worry about that.
So
it happens automatically.
It happens automatically, exactly. So for most of us who can't track accurately enough, we're automatically dithering. But there's a problem, and I discovered this problem. I always mounted my camera square, just like we all would. I want everything all fixed and square. I put my camera square with one of the RA axis when I set up my scope. Well, what happens is later at night you're imaging, and the mount is tracking up in RA. And whatever residual flex or mirror flop I have left in my system causes over 3 hours my images to dither themselves a little bit. And the images will drift just a little bit as I'm imaging. But the problem is if my camera is square, that drift is going to be vertical along the RA direction. And then dithering doesn't work anymore because what you're trying to do with dithering is to remove the read noise from the camera and this column noise. And if your images are shifting vertically, it actually gets worse because you're shifting your images in the same direction that the read noise is inherent in your image. And I'll show you, if you've ever seen it, you've done a really good job of calibrating and you stack and you stretch and then you see the streaks in your images. Sometimes it's what that's due to is these images, this dithering, unnaturally in the wrong direction. So what I do is I just shift my camera over 45 degrees. So that now the natural dithering occurs along the diagonal. And it naturally dithers for me. Every image when it shifts, it's shifting away, it's moving a column.
So you just turned the camera body 45 degrees?
Just change your camera body to 45 degrees. And you'll find your drifts are now diagonal and not vertical. And that helps. It actually really helps.
Okay, let's see if I understand. You're going to take a series of pictures with the camera oriented one way, and at some point you're going to loosen it and rotate it, orient it another way?
No. I mean, I've got taking a series of images with the camera all square, and I'm trying to keep everything settled. It's just that my mirrors, after an hour of doing that, if I find that when I'm stacking my images, that my images are drifted because of mirror flop or because of flexure. And so that's why I have to stack. That's why we all have to stack our images. That's why we have to align our images before we stack them because of this drift. Well, if you're too fastidious about lining everything up, you find that your alignment error, your your alignment error when you stack the images is sometimes vertical, it's sometimes along the RA axis. It's because that's the way you're tracking along RA. So you don't really want that to happen.
An angle.
You want it to be at an angle.
I've got my camera set
Set
parallel to
clockwise.
the tube, but I've noticed every time I go to stack them, they always drift up to the right.
Up and to the right.
Up and to the right.
That's what you want.
My point is the same as yours. It's always an RA.
It's always
And
in
I'm always, I'm learning something, because then I've always got my camera square. And I got the lines.
Yeah, all nice and lined up.
Yeah.
Well, I don't do that anymore. I cock over to the side. So you'll see a difference. We're almost there. I'll show you something. All right, I think this is it. So let's go to some processing. I figured what we should do is just go through a standard processing, and then we can maybe do something a little more involved. So anyway, the basic philosophy here is less is more, right? You really don't want to over-process your image because you basically destroy it the minute you start. And just like a plan, it's very important to keep a processing log and just open a text file. When I start processing, every time I do something, I just write what I'm doing. Because Jeff told you this last time, it's very true. You will process an image 4 or 5 times, and then you'll think, oh, the third time is the best. What was I doing? And so you really need to have a log, go back and find out what was working. Because it changes every time, and you're never going to process 2 images the same way. So let's do this. That's what I figured.
Here till 9.
Here till 9.
Then we're south by 9, so
Okay, we're good.
10 minutes before.
So let's go through an example where I'm going to assume is that we've already calibrated, we've already aligned, we've already stacked, and now we're ready to process this thing. And we'll go through an example. It's not going to be one of the best pictures I've ever taken. It's not going to be one of the worst. It's not even going to be. It's going to just be kind of an average, challenging thing, which has got involved playing with a lot of different things. It's got a few problems, but not.
So if you're using DSLR, so your red, green, blue are already aligned to each other.
That's correct.
So those of us would be taking separate exposures for red, green.
If you've got a CCD, right, then I will leave you on your own to assemble an RGB.
But I think that once you get all those aligned, then the processing remains the same after that.
That's right. Yeah, once you make that RGB. I actually do it a little bit. I mean, I do. There's a method of processing of calibrating your DSLR color image, which does the calibration before you do the Bayer mask correction. And I do that, and then I do. It's a little bit like a CCD. I manually do a Bayer correction later, and it's a little more accurate. But we won't go into that part today. Let's assume we have a stacked color RGB image at this point. We'll go ahead. So let's look at, in my case, the steps. We'll look at color correction, stretching, how to deal with star glow, how to think about detail enhancement like sharpening. Is it always a bad thing to do? And how to keep that from ruining your image. Gradient removal, noise reduction, and then we're basically done. It's just, yeah. And I wanted to spend a little bit of time talking about layer masking because it's more and more I do, the more I find how valuable it is to cheat in image processing. So I'm actually going to combine the two. That's going to be 2 separate things here. I found an image where we can do both of these together. And we'll get started at this, and we'll get down to here, this layer detail enhancement, and we'll realize that it's not going to work unless we do layer masking. And so we'll finish this image off with layer masking. And I don't know if we'll have time here, but actually, what I would like to do is show you just a cool thing we got started, just in case we don't count. I don't know if you most of you guys have probably seen this thing. This is this Hubble and Chandra movie of inline. Everybody seen this? It's a time-lapse image at the core. This is Hubble, and this is Chandra, the X-ray space telescope. And so this is the core. This is a neutron star right here in the middle of